Okay, let's look at some special topics here. So we're only looking at 2 sections in Chapter 11. Don't be intimidated by the later chapter material. It's just some special topics we're looking at. So the first, we're going to look at 11.1, and then there'll be a video for 11.3. But so what we're going to look at here is we're going to look at another type of equation or function called absolute value functions. So nothing too sophisticated here. We're just looking at absolute value. So what is absolute value? Well, the definition of absolute value is the distance from that value to 0 on a number line. That's it. And that's all it is. So if I'm taking the absolute value of -6, that just means, so if I drew that on a number line, well, that represents the distance -6 is from 0 on the number line. So here's -6, right? And here's 0. So how do you measure that distance? That distance right there that's a measure of 6 units. That's why we could say the absolute value of -6 is 6. That's it. Because it's 6 units. And it's the same thing if I take the absolute value of 6. Well, 6, that's 6 units from 0 as well. That's why a lot of students make this mistake, is that they think that absolute value means it's positive. Well, yes, it's true, but that's not what absolute value represents. The absolute value, by definition, is a measure of distance from a starting point. In this case, it was -6, but it just depends what you're taking the absolute value of. That's it. That's all absolute value means. It's a distance. That's what it is. And distance has a large meaning in mathematics. You'll see in 11.3. So what is the function? Remember function notation? What does the function of absolute value of x look like? Well, if you recall from, much earlier in the course, right? When we graph things, what was like one of the first ways we learned how to graph things? We plotted points, right? We made a table of random x values, and we saw what their corresponding y values were. So I could plug in any value I want for x. So let me do my, my 3, right? I guess I could tack one more on there. Big deal, right? Well, what's the absolute value of 0? So, the absolute value of 0 is just, what we're saying is, how far is 0 from 0 on the number line? 0. Duh. How far is 1 from 1 on the number line? That's the absolute value of 1, which is 1. And so on. The absolute value of 2 is 2. How far is -1 from 0 on the number line? That's a unit of 1. So that means the absolute value of -1 is 1. Right? In other words, if I just plug these values in for x into my function for the absolute value of x, I get those values for y. So if I plug in these ordered pairs onto my graph, or if I plot them on my graph, right? So 0, 0, that's easy. I mean, they're all easy, but I'll go through it anyway. 0, 0, 1, 1, right? 2, 2, so to the right 2, up 2. -1, 1, which is to the left 1, up 1. And, if I wanted to put another, let me squeeze another point in there, so just to be symmetric. The absolute value of -2 is also 2. So, -2, 2. So our graph, takes this shape. And that's the basic structure of the absolute value of x. It basically looks like a V, where the point of the V is at the origin. That's the basic structure. That's the basic graph of the absolute value of x. You know, if you take college algebra, we'll actually shift from this. Well, you know, what if the absolute value of something else? Well, if it was the absolute value of x minus 2, how would that look like? And you learn in college algebra techniques of shifting and stretching and stuff like that, but we don't look at that in Math 105. But anyway, if I look at my calculator, you could actually find the absolute value function in your calculator. It's built in. So if you go to the Math button, and if you go down, I think it's at number, yeah. So if you press Math and you go to NUM, the first thing you see at the list is ABS. That's absolute value. So if you hit enter there, it'll give you the absolute value symbol. Now, if you're using a TI-83 and not an 84, you won't see the actual symbols. You'll just see the words ABS. That's it. It just means absolute value. So if you want to graph this function, just go to y equals. Let's get rid of that. Type in, so go to Math, num, absolute value, x. Hit enter and graph it. You'll get the absolute value graph, and there it is. Again, you know, pretty standard, pretty basic, but that's what the basic absolute value of x looks like in your calculator. You know, nothing too tricky there. Pretty standard. So, all right. Well, what if we have absolute value equations we want to solve? So, if we actually have some equations you would like to, you'd like to solve. Well, it's all a matter of, basically it's just a matter of if we have an absolute value of some expression equaling a number, right? What we could do is we could drop the absolute values and just write two equivalent equations, right? Because if you take the absolute value of something, what that's really saying is it has two possible values, a positive value and a negative value. So if we drop the absolute values, we could get those two equivalent statements. That would be equal to a negative value, or it would be equal to a positive value. And that's exactly what I just described right here. So the idea here is you want to isolate the absolute value symbol, and then you could just apply this property. Just drop them and make two separate equations and then solve for x. So if I have this equation right here, you can see the absolute value symbol is isolated, so I could apply this rule here. I could apply that statement. So what I'll end up getting is I could just drop the absolute value and get 2x minus 5 equals 11, or now I could just say, oh, I'm sorry, we're going to take the negative one first. So 2x minus 5 equals negative 11, or 2x minus 5 equals 11. It didn't matter if I did this one first or this one first. It doesn't matter. I just want to be consistent with up here. But the point is that once the absolute value symbol is isolated, you could drop the absolute value and just write these two equivalent equations. And that's implying the same thing. So now if I just got to solve each equation for x. So, you know, this is a linear equation, so you're pretty much pros at this by now. Add 5. 2x equals, so negative 11 plus 5 is negative 6. Divide by 2. X equals negative 3. 4. So now add 5. 2x equals 11 plus 5 is 16. Divide by 2. x equals 16 over 2 is 8. Okay. So, I want to stress something here that's kind of important. Make sure you check your solutions. Make sure you check your solutions. So, plug this into the original equation and see if you'll get 11. So, if you remember, back when we did polynomial equations, and you could do this for any equation, you could store that value in your calculator. Remember I showed you that? So let's do that. So let's store -3. So -3. Remember the store button is right here. Store into x, hit enter. Now just type in the equation and then see if you get 11. So we need the absolute value, so math, num, absolute value of 2x minus 5, so 2x minus 5. Hit enter. I get 11. Alright, that means -3 works. Now let's try 8. So 8 store x, and now let's type in the equation again, and I get 11. Hey, that's great. That also works. So now that I checked my solutions, I could define my solution set. So my solution set is the values -3 and 8. It's very important that you check your solutions, because I cannot stress this enough. That's very important, because sometimes, depending on the equation you have, one of these solutions that you got here may or may not, they may not work. So you have to check them. Don't just solve it and then assume that they're the solutions, because they're not. Alright, let's look at this one. Alright, so again, make sure you isolate the absolute value. Make sure you do that first. So remember, I want the absolute value by itself. The absolute value here isn't by itself yet. So I got to put it by itself. How do I do that? I need to get this by itself. So before I, apply this rule here, I have to subtract the 4, right? So what will that give me? That'll give me 5 times absolute value of x equals 24 minus 4 is 20. And then divide by 5. So I have the absolute value of x equals, well, I don't know why I did that. 20 over 5 is 4. Now that this is by itself, now I can apply this rule. So this means x equals 4, or x equals -4. Again, you could write -4, +4, or vice versa, it doesn't matter. So this just breaks into those two, just like this broke into these two. Now that I was able to do this, well, as it turns out that, I don't have to solve for x now, because x was already solved for, which is good, that's fine. So, okay. So remember, check your solution. So let's take 4, store that in for x, and then type in, now let's type in my original equation and hit enter. So 5 absolute value of x plus 4 Gives me 24. Hey, great, that works. Now let's try -4. And enter. I get 24, which also works. So my solution set is the values -4 and 4. So don't forget to check. Don't forget to check.